Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, today we are going to start with the second part of the chemical bonding part 2. So let's start with the session. So here in this session we'll be learning single bond, double bond and triple bond, the types of covalent bond. So before starting, let's revise the last session so that we can have a proper learning. Friends, we know that there are two types of chemical bonds, electrovalent bond, we can also say that in ionic bonds, and covalent bond, where electrovalent bonds are formed by the transfer of electrons from one atom to another, whereas covalent bonds are formed by the sharing of electrons between two atoms. Friends, we have here covalent bonds as a non-polar and polar. Now what is this covalent, non-polar and polar? Basically, the ability of an atom to attract or to share the electrons of the bond towards it is actually called electronegativity of the element. With this concept, we have non-polar covalent bonds and covalent bonds, where a covalent bond in which there is an equal attraction of the shared electrons between two combined atoms is called non-polar covalent bond. We can also say that a non-polar covalent bond is formed when two atoms having equal electronegativity combined. In other words, a non-polar covalent bond is formed between the same type of atom. For example, we can take the hydrogen atom. Two hydrogen atom makes H2, whereas polar covalent bonds are those in which there is an unequal attraction for the shared electrons between two combined atoms, resulting in one end of the molecule becoming slightly positive and another becomes slightly negative, as it is formed when two atoms having different electronegativities combine. You can see here there are two signs I have written. We call this delta plus and delta negative. It should be noted that the small positive charge, delta positive and delta negative, on the two ends of the compound, or you can say the two elements, do not make that it is an ionic substance, as the bond between these elements, or you can say two atoms, is predominantly covalent, but it has some ionic character in it. In fact, the polar bonds are intermediate in nature between ionic bonds and pure covalent bonds. So I hope you have now revised. Let's start with the session now. So the first type of covalent bond, we call it single bond. Actually, a single covalent bond consists of one pair of shared electrons. In other words, we can say that a single bond is formed when the sharing of one pair of electrons between two atoms. We can have an example here. I've taken the example of hydrogen, where there is a sharing of only one electron each, like the two dots drawn between the hydrogen atom represent the pair of shared electrons which constitute a single bond. Alright, we can also show or donate a short line between two atoms to show the bond. Now let's come to the example. Like this is an hydrogen with the one single bond, and these are the sharings of electron. So we say this, that the shared electron pair is always drawn between two atoms. Alright? As a hydrogen atom is very reactive and cannot exist free because it does not have the stable inert gas electron arrangement. So hydrogen gas does not consist of the single atom, it consists of more stable H2 molecule. Each molecule of hydrogen gas has two hydrogens joined by a covalent bond. Let's explain now. See, the atomic number, we know that hydrogen is 1, so its electronic configuration is K1. Hydrogen atom has only one electron in the outermost shell, and this is not a stable arrangement of electrons. As a stable arrangement is to have two electrons in K shell, because the helium is more stable than the hydrogen gas. As hydrogen atom needs one more electron to become stable. It gets the electron by sharing with another hydrogen atom. So the two hydrogen atoms share one electron each to form hydrogen molecule. You can see here I have written H plus, and 2H becomes H is to H, which we can also write a small dash between them to form a bonding. Here is the H2 molecule with a single bond. Now friends, let's come up to the notes. So the single covalent bond consists of one pair of shared electron. One pair of electron means two electrons. A shared electron pair is always drawn between two atoms. We can also say that the covalent single bond can be represented by a short line between two atoms of the element with a dash between them. I hope you have understood now the single bond. Let's come to the double bond. Now what is double bond? A double bond covalent bond consists of two pair of shared electrons. In other words, I can say that the double bond is formed by the sharing of two pairs of electrons between two atoms. And two pair of electrons means four electrons. So we can say that double bond is formed by sharing of four electrons between two atoms, each atom contributing two electrons for sharing. Let's take an example. I take an example of oxygen. We know that oxygen is very reactive, as the atomic number of oxygen is 8, so electronic configuration is 2 6. Thus an electrons of the oxygen is 6 in the outermost shell. Since an oxygen atom has 6 electrons in its outermost shell, therefore it requires 2 electrons to have inert gas configuration, right? Which is a stable configuration. So the oxygen atom gets these electrons by sharing its 2 electrons with the 2 electrons of the another oxygen atom. So we can write like this. This is one with one another with 6 electrons in the outermost shell. So now we have a pairing, right? So this is basically a double bond, that is sharing of two pairs of electrons, right? So it gives us a double bond like this. We can write like this. Since the oxygen atoms share two pairs of electrons, the bond between them is called a double covalent bond, or just a double bond. Thus, in the oxygen molecule, two oxygen atoms are held together by double bond. You should note that it is a stronger than single bond. Now friends, let's come up to the notes. So the double bond is formed by sharing of two pairs of electrons. A pair of electron means four electrons between two atoms, each atom contributing two electrons for sharing. Double bond is combination of two single bonds. This bond is stronger than the single bond, therefore more stable molecule. The double bond can be represented by two short lines like this. So now we come up to the triple bond. So a triple bond consists of three pairs of shared electrons. as a bond is formed by three pairs. So there is a 6 electrons which take part in the bond, as a triple bond is actually a combination of 3 single bonds. So it's represented by putting 3 short lines between 2 atoms. Let's take an example of nitrogen molecule which contains a triple bond. You can see here. Let's come up into the more details. So we know that nitrogen molecule is also very reactive and cannot exist in a free state because it does not have the stable electronic arrangement of inert gases. So what is the atomic number of nitrogen? It's 7, and the electronic configuration is 2,5. So it need for inert gas configuration, how much it need? 3, right? So let's write down. There are 5 electrons in the outermost shell of nitrogen. It needs 3 electrons to get a stable molecule. So here you see a triple bond. 6 electrons takes part in this bond. 3 pair of 3. So we write 3 pair of electrons are shared. So we get like this, or we can also write into a stable molecule. Since the nitrogen atoms share 3 pairs of electrons among themselves, the bond between them is called triple bond. Thus, in the nitrogen gas molecule, the 2 nitrogen atoms are held together by a triple bond. In the nitrogen molecule, each nitrogen has 8 molecules in the outermost shell. Now it is more stable than the nitrogen atom. So friends, we have now a triple bond consists of 3 pairs of shared electrons. A triple bond formed by sharing of 6 electrons between 2 atoms. It combines, or it is a combination of 3 single bonds. The molecule is more stable than molecule having single and double bond. Now, who do you think is more stronger? Yes, the triple covalent bond is much stronger and shorter. Then it comes to double bond, then single, ionic, and then hydrogen bond. Yes, if you've been asked which bond is much weaker, you can say that the hydrogen bond is much weaker. That means it is much easily reactive in the chemical reactions. So friends, let's come up to the properties of electrovalent compounds and covalent compounds. So electrovalent compounds or ionic compounds consist of ions. For example, sodium chloride is an electrovalent compound which consists of an equal number of sodium ions Na plus and chloride ion Cl minus. So there is nothing like sodium chloride molecule. Second, electrovalent compounds or ionic compounds are usually crystalline solids, as the ionic compounds are solid because their oppositely charged ions attract one another strongly and form a regular crystal structure, as the crystal structure of ionic compounds are hard and brittle. Third, electrovalent compounds or ionic compounds have high melting point and high boiling point. As the electrolytic compounds are made up of positive and negative ions, there is a strong force of attraction between the oppositely charged ions. So a lot of heat energy is required to break this force of attraction and melt or boil the electrolytic compound. Due to this, electrovalent compounds have high melting point and boiling point. If a substance has a high melting point or boiling point, then we can say that it is an electrovalent compound and consists electrovalent bonds. Fourth, we can describe that they are soluble in water, yes, but they are insoluble in organic solvent like ether, acetone, alcohol, benzene, etc. For example, sodium chloride is soluble in water but insoluble in organic solvent like benzene and kerosene oil, as the ionic compound dissolved in water because the water has a high dielectric constant due to which it weakens the attraction between the ions. The organic liquid like benzene and kerosene oil cannot do this. Last, electrolyte compounds or ionic compounds conduct electricity when dissolved in water or when melt. That is, electrovalent compounds are electrolyte. They conduct electricity because they contain charged particles called ions. Whereas we can have equivalent compounds as they consist of molecules. For example, carbon tetrachloride is a covalent compound which consists of CCl4 molecule. So they're nothing like ions of carbon tetrachloride compound. Second, they are liquid or in a gaseous state because the covalent compounds are usually liquid due to the weak force of attraction between the n molecules. So the covalent compounds have usually low melting point and low boiling point. For example, naphthalene has a low melting point of 80 degrees centigrade and carbon tetrachloride has a low boiling point of 77 degrees centigrade. As the covalent bonds are made up of electrically neutral molecules, so the force of attraction between the molecules of a covalent compound is very weak. Only a small amount of heat is required to break these weak molecule force, due to which the covalent compounds have a low melting point and boiling point. You should also know that the covalent solids like diamonds and graphites have a very high melting point and boiling point. The covalent compounds are usually insoluble in water, but they are soluble in organic solvents. As is the polar covalent compounds like hydrogen chloride and ammonia are also soluble in water, but they're actually insoluble in water just because of their bonding. Last, the covalent compounds do not conduct electricity but because they don't have any electrically charged ions like glucose, cane sugar, urea, alcohol, carbon tetrachloride. They do not contain electricity because they do not contain ions. So they cannot be electrolyzed to get back into constituent elements. So friends, here I end up with the session, both the sessions. I hope you have understood the whole session. Now it's your time to do an activity. I have given three simple questions. First is distinguish between electrovalent bonds and covalent bonds. You have to give examples of single, double, and triple bonds. Third, what is polar and non-polar covalent bonds? So in next session, we'll be starting a very new session of the periodic tables. Thank you. Thank you for watching Edupedia World videos.